Welcome to the part 3 of season 1 in the Keio ICU International Christian University Linguistic Colloquium. I'm Seunghun from International Christian University, and this event is co-hosted with Shigeto Kawahara at Keio University. Today, we have two talks, one by Misaki Kato of University of Oregon, and the other one by Claire from UCLA. So let me give Shigeto a chance to introduce Misaki.
All right, my pleasure. I'm Shigeto Kawahara from Keio University. Misaki is a graduate student at the University of Oregon, as Seunghun said, and she's almost done. I got to know Misaki when I started a collaborative experiment with Professor Kaori Idemaru at Oregon on the contextual effects of the perception of geminates. And during this collaborative process with Professor Idemaru and Misaki, I was pretty impressed by her research skills in general. Her literature review is extremely comprehensive, and her oral syntax is very well written, much better than what I usually write. And she also happens to be my Zoom teacher as well when this chaos started in March. For her research, Misaki mainly works on the phonetics of L2 speech, both in terms of acoustics and perception. She already actually has a paper published in Journal of Phonetics, which I can almost be jealous about. And she has already given talks at major phonetics conferences as well. So she sounds like a great researcher to hear from. So without further ado, let's hear from Misaki.
Thank you. Let me share my screen first. Okay. Can you see the screen?
Yes.
Okay, great, thanks. All right, so thank you for having me here today. I'm really excited. Today, I'm going to present a research project titled Acoustic Characteristics of Foreign Accent in Alto-Japanese, a cross-sectional study. This is a collaboration project with Dr. Kaori Idemaru and Dr. Kimiko Tsukada. So first, I would like to briefly introduce what I examined in my research overall. So my research is situated at the intersection of acoustic phonetics, laboratory phonology, and language acquisition. I care about how talkers, how talkers and listeners together make speech communication successful, and also how acoustic characteristics of speech impact this process. I also care about how people with different linguistic backgrounds communicate with one another. For example, communication between a native talker and a native listener, also between a non-native talker and a native listener, or between a native talker and a non-native listener, or between non-native talker and non-native listener of the same or different native language backgrounds. So my long-term goal is to better understand how speech communication between people who have different language backgrounds is impacted by factors that's related to talkers or listeners and the acoustic characteristics of the speech itself. In today's talk, I'm going to focus on the question of how characteristics of talkers impact the acoustic characteristics of the speech that they produce and how their speech is perceived by listeners. So previous studies examining perception of accented speech show that many second language learners retain a foreign accent in their speech. And listeners are very good at detecting a foreign accent. Perceptual consequences of foreign accents have been examined broadly. For example, listeners perceive accented speech to be not easy to understand or less credible compared to non-accented speech, even when they understand the content of the accented speech just fine. So we know that the presence of a foreign accent impacts listeners' perception a lot. But what we know much less about is what actually is the source of a foreign accent. Of course, it is possible that some speaker characteristics impact perception of a foreign accent, such as the onset age of learning. But in terms of what are the acoustic sources of foreign accents, the results are rather mixed. Some studies show a stronger influence of segmental features over prosodic features. So segmental features are, for example, characteristics of consonants or vowels. And prosodic features are features such as global rhythm, intonation, fluency, that sort of things. But other studies show the opposite pattern, showing a stronger influence of prosodic features over segmental features. Why is that? Well, one possible reason is that acoustic sources of foreign accents differ for the speech produced by learners who are at different stages of learning the second language. So in the current study, we asked what are the acoustic sources of foreign accents in second language speech for native listeners. We also asked, do the predictors change across learners of different proficiency levels and learning backgrounds? We examined these questions in Japanese as the target language to broaden the scope of the research on foreign accent speech. Specifically, we examined acoustic cohorts of foreign accents of L2 Japanese learners across different instructional levels and learning backgrounds. So we recruited native English talkers from different instructional levels of Japanese. We recruited beginning level learners from a first-year Japanese class at University of Oregon and intermediate level learners from second and fourth year classes. We also recruited heritage learners of Japanese. So again, these learners are all native English talkers and also native speakers of Japanese. The materials were 6 short Japanese sentences as shown here. They were chosen from a beginning level Japanese course textbook. The talkers from the previous slide recorded these sentences in a delayed repetition task. In this task, for example, in each trial, they first heard a male voice say, "Nihongo no kurasu wa dou desu ka?" meaning, "How's your Japanese class?" Then they heard a female voice say, "Tanoshii desu yo." This is the modal production of the test sentence number 1 here. And then they again heard the male voice saying, "Nihongo no kurasu wa dou desu ka?" And they were prompted to produce the test sentence, "Tanoshii desu yo." Just so you have a better idea of what the learner's speech sounded like, I'm going to play the test sentences produced by a beginning level student, that's the blue line here, and an intermediate student, that's the green line, and the heritage learner.
楽しいですよ。楽しいですよ。楽しいですよ。
Now the second sentence.
車が買いたいです。車が買いたいです。車が買いたいです。
Third sentence.
日本語の辞書が欲しいですね。日本語の辞書が欲しいですね。日本語の辞書が欲しいですね。
The fourth one.
大学の隣にありますよ。大学の隣にありますよ。大学の隣にありますよ。
Fifth one.
明日は映画を見たいですね。明日は映画を見たいですね。明日は映画を見たいですね。
The last one.
6時に起きます。6時に起きます。6時に起きます。
So for the speech samples collected in the delayed repetition task, we made a series of acoustic measurements. To characterize segmental features, we measured F1 and F2 of vowels. So F1 and F2 are the things that differentiate vowels from one another. These values were measured at midpoint of the vowels for 5 short vowels and 2 long vowels. We also measured closure duration and voice onset timing of voiceless stops T and K. To characterize prosodic features for each sentence, we analyzed characteristics of speech rhythm. So vowel V and vowel C is the standard deviation of vowel durations and consonant durations in each utterance that is corrected for speech rate. Vowel % is the percentage of the total duration of vowels in each utterance. And PVI is the deviation of durations of vowels in adjacent syllables that is corrected for speech rate. This CVV/CV, it's a vowel duration ratio. Basically, it's the duration of CVV with the long vowel that's divided by the duration of CV with the short vowel. We also measure some other types of prosodic features. For the tonal measure, we counted the number of pitch accent errors made by the learners. So in Japanese, pitch accent can make a lexical difference. For example, hashi is chopsticks and hashi is the bridge. And learners could produce correct sentences in terms of segments, but they could produce them with wrong pitch accents. That's why we were interested in this tonal measure. So to count the number of pitch accent errors in learners' productions, we use native Japanese talkers' productions as the target pitch accent for the test sentences. The learners' pitch accents that did not match the targets were counted as pitch accent errors. We also measure characteristics of fluency, such as pauses and articulation rate. In the next slide, I'm going to demonstrate how we coded the pitch accent error. So to demonstrate an example of how we coded this pitch accent error, here's a native talker's production of the first test sentence, "Tanoshii desu yo." I'm going to play the sound.
楽しいですよ。
The key point that I would like you to pay attention here is that it starts with the low here and goes up. I'm gonna play it one more time.
楽しいですよ。
And here is a learner's production. It's a bit harder to see the intonation here, but that's the blue line here. But the key point is that this person does not start with the low at the beginning. And that's the error here. I'm going to say, play the audio.
楽しいですよ。
One more time.
楽しいですよ。
Right. But other parts of the pitch accent patterns are correct here. So this utterance was scored as a pitch accent error of 1. Talker speech samples were also evaluated by native Japanese listeners in the accentedness rating task. In the rating task, the listeners heard one sentence at a time, and then they rated the sentence by moving a slight bar on the visual analog scale, something like this. And the ratings were Z-score normalized for each rater. So I'm going to show you the structure of the results here. First, I present the results of the exploratory analysis. We used random forests to examine relative contribution of the acoustic variables to perceived accentedness. In this analysis, what we did is that we put all the acoustic variables, such as vowel duration, the number of pitch accent errors, and pause frequency, into a model to find out which acoustic variable is the best, or second best, or the third best at predicting variation in listeners' accentedness ratings. Specifically, we asked what is the relative importance of the acoustic variables for perceived accents. Also, we asked, do the important variables differ for perceived accents of learners in different instructional levels and different learning backgrounds? I will then present the results of the confirmatory analysis, where we examine the effects of important acoustic variables that are identified based on the exploratory analysis on perceived accents. So we first examine relative importance of predictors for all the talker groups data pulled together. And this is the results of the top 10 predictors. The top ones here are the most important predictors. This shows that 3 of the 4 most important variables were prosodic variables. So this clearly shows that the pitch accent error was the most relevant variable to the accentedness ratings. And other important prosodic variables were the vowel rhythm measure and the articulation rate. Now we look at the relative importance of predictors for each talker group's speech. So in this plot, the upper left plot is the beginning level learner's speech. The upper right plot is for the intermediate learner's speech. The lower left is for heritage learner speech, and the lower right here is for native Japanese talker speech. So to briefly summarize the patterns here, we see that beginning and intermediate learners shared many of the top 6 acoustic variables, which are the articulation rate, the vowel duration measure, vowel percent, pitch accent error, and all of these variables were prosodic variables. But for heritage learners' speech, the pattern was the opposite. Segmental variables were more important than prosodic variables. Another observation that we could make here is that for the beginning level learner's speech, that's the upper left corner here, sentence was the most important variable. This suggests that sentence by sentence variance in these learners' speech affected their perceived accents the most. And acoustic variables that we examine here did not really map straightforwardly onto their perceived accents. In the next analysis, we examine the effects of some of the important variables here, such as pitch accent error and articulation rate, on listeners' accentedness ratings. So based on the exploratory analysis shown earlier, we selected 5 important variables: pitch accent error, articulation rate, CVB, CV ratio, F2N-A, and percentage of vowel duration invariance. The effects of these variables on accentedness ratings were tested in a confirmatory manner using hierarchical linear regression modeling. This shows the correlation between 5 acoustic variables and accentedness ratings. Each data point here represents a speaker. So the accent ratings by speaker groups are also shown here at the bottom right. It is clear that accent ratings differ by speaker groups. So the beginning level learners were perceived to be the most accented, followed by intermediate learners, heritage learners, and native talkers. For the 5 selected acoustic variables, all of them significantly improved the modal fit, except for F2N-A, which was only marginally significant. There was also an interaction between pitch accent error and one of the group terms. This suggests that the effect of pitch accent error was greater for heritage learner speech than for the instructed learner speech. I'm not going to too much detail here, but I will be happy to answer any questions regarding this point during the question period. So to summarize the findings, in terms of the relative importance of acoustic variables on perceived accents, overall, pitch accent error was the most important predictor. And other prosodic variables such as vowel duration measure and articulation rate were also important variables. This suggests that there is strong influence of prosodic variables on perceived accents of L2 Japanese in general. We also observed that the relative importance of these acoustic variables differed across groups. That is, for classroom learners' speech, prosodic variables were more important predictors than segmental variables. But this pattern was the opposite for heritage learners' speech. For their speech, segmental variables were more important than prosodic variables. So these results suggest that learning Japanese prosodic features may be inherently more challenging than learning segmental features for native English learners. It could be because the L1 English and L2 Japanese differ a lot in terms of prosodic features, but L1 English segmentals map easily onto L2 Japanese segments. Another observation that we made is that the acoustic variables that we examined here did not really characterize the variation in perceived accents for beginning level learners. This was a bit surprising, as listeners clearly thought that beginning level learner speech was more accented than other speaker group speech. It's just that the beginning level learner's perceived accent was not characterized by the acoustic variables that we looked at here. It's possible that these beginning level learners' speech deviated from native speech rather randomly, as we saw that the sentence by sentence variance affected their perceived accents the most. I could speculate more on this if you're interested during the question period. So going forward, I think it would be interesting to investigate questions like whether acoustic features contributing to perceived accents differ from those impacting other measures such as intelligibility of the speech. For example, it's been shown that non-native talkers could increase intelligibility of their speech when they're asked to speak more clearly, but their perceived accentedness does not really differ. And my dissertation also investigates extensively regarding foreign accentedness of the speech produced by non-native talkers of different proficiency levels and how it may be related to their speech intelligibility. Literature also suggests that perceived foreign accents can be influenced by listener-related factors, such as their own foreign language experience or cultural expectations about certain accents. And also whether or not they have gone through a short-term training of listening to accented speech. So these studies shown here, they demonstrate that listeners get better at understanding accented speech after a short period of exposure, but it may be worth exploring whether they also perceive less foreign accent after such short training. So in conclusion, the relative importance of acoustic variables impacting perceived accents differ for the speech produced by classroom learners versus heritage learners of Japanese. And this suggests that different acoustic features may need to be targeted in pronunciation instruction for learners with different learning backgrounds. Finally, I would like to thank my collaborators, Dr. Demaru and Dr. Tsukada, and Haley Brown for helping us collect data, and the organizers of this fantastic series of talks, Dr. Lee and Dr. Kawahara. With that, I would like to end the presentation, and thank you so much for listening.
Thank you. As I announced earlier, I'm Seunghun Lee. If you have a question, please send your name and affiliation to Seunghun Lee. So the first question comes from Dr. Toshio Matsuura from Hokusei Gakuin University. Please unmute yourself, and if possible, please turn on your camera before asking a question. Yes.
Thank you for interesting talk. My question is that, do you think, so pitch accent is important feature in perception of accentedness, right? So do you think the result is reflection of Japanese word recognition by native Japanese speakers?
That's a very good question. Yes, I think it's relevant to some extent because the listeners that we looked at here, the listeners who rated the speech samples were native Japanese listeners. So that could very well reflect their way of recognizing the speech, their way of sort of evaluating the speech. So for example, if we sort of recruited different types of listeners, let's say non-native listeners of Japanese, their perception of accent could as well may well be different from native Japanese listeners' way of evaluating the speech, for sure.
Thank you.
Thank you.
Next question comes from Shigeto Kawahara, Keio University.
Well, thank you so much. I learned a lot. This is kind of a new area for me. So I have one question that's related to Matsuura Sensei's question and also a clarification question. The first question is, can you show us the slide where you compare the pitch of the non-native and the native?
Yes. Give me a second. Let me go back. Okay.
Yeah, so one difference that struck me auditorily as well as on this spectrogram is the extent of the final rise. So the native speech has a clear rise, and the non-native speech sounded really flat toward the end. But you didn't code this, right?
Right. So what we basically focused on was the low start and the pitch accent on the she, like high start here, and whether it's going down. There were a lot of kind of a lot of variations in native talker speech in terms of the final yo. So we mostly looked at the.
I see. So there wasn't really like
sentence.
Correct phrasal accent. That's why you did it.
Right, yeah, we looked at native talkers. There were 10 native talkers productions. Productions from 10 native talkers. So we looked at their productions as their target, and then if there is kind of a lot of variations, it was sort of hard to come up with what is the correct one here. And the yo here is kind of a good example for the variability that native talkers showed, I think. But so there were 3 coders, including me, and Dr. Edmar and Dr. Tsukara, and then we all did the coding, and then there was a disagreement. We sort of talked about it, and then we agreed on the coding. That's like the final coding, yeah. Okay,
thank you. I guess the second question is really like coming from my ignorance, but can you tell us a bit more about Vaco delta V? I don't know this measure. Yeah. So what's the expectation? Do you find Vaco delta V? I think that's one of the measures that you used.
Yeah. So that was for the. I don't know if I'm still sharing the screen, but
not in your face.
Probably not. Right. Sorry. It's just my face. Yeah, so that's one of the standard measures that we looked at from the previous studies. And then it's like how vowel durations and consonant durations also sort of deviated from, it's kind of, hard to explain, but it's basically one of the global rhythm metrics, and how
so
sort of.
Expectation is, since Japanese is kind of more a timing language, you expect vowel durations to be more or less constant across the context, whereas English is stress time and there's vowel reduction, so there's more variability in vowel duration. Is that the idea?
Right, so maybe the CVV/CV, the one of the global measure that I talked about, maybe sort of a good example to talk about this. So that's like, maybe I should show the screen here. Let me, if I can share the screen. Okay. Am I sharing the screen now?
Yeah.
Okay, so yeah, this measure, for this, we, so for native, the expectation is that native talkers are going to use long vowel when there is a long vowel. So for example, so there were 2 long vowels that we looked at, and then the expectation is that speakers should produce longer vowel as with longer duration and shorter vowel with short duration. So there will be some variability here, that's the expectation. But if there's less variability for this vowel duration measure, then that we took it as a sign of some deviation in terms of vowel duration. Does that make sense?
Yeah, but this measure in Vaco delta V, I feel like they're tapping different prosodic properties, because CVV/CV is whether the learners learned long vowels or not. Whereas Vaco delta V, are we tapping like more isochrony? I'm trying to. Yeah.
Right, that's like one way of characterizing that. I think it's a really good question. I might have to get back to you on that, because I need to probably look at the data and look back at the data more closely, and I can definitely get back to you on it.
All right, sounds good.
Thank you.
Thank you.
The next question is from Yoichi Mukai at University of Alberta.
Can you hear me now?
Yeah.
Great presentation. Yeah, really interesting. Thank you. I have a few questions about your regression models.
Sure.
Can you show us the screen again?
Yes. Give me a second.
Just curious about the correlation between the variables you put into the model. I assume that they are correlate to each other, but I'm not sure.
Right. So it's looking at how each of the predictors significantly sort of improve the model fit for accentedness ratings.
So you put all the variables into the single model.
Right, and then I subtracted it like one by one, and then see if that makes a difference.
Right. Just I'm curious that if all the variables are collinear each other, you shouldn't be put everything together. That's I just wanted to make sure.
Right. Yeah, I'm not sure how to answer that question right now. You're talking about collinearity of the variable.
Yeah, simply
right?
that's yeah.
Right.
Because I thought the reason that you use a random forest is to avoid that kind of issues, but
right, that's a very good question actually. So we tried to first put all the predictors. So we have like 20 something acoustic variables in our data, and then it would probably result in a very sort of complicated model. And then we were just trying to get a sense of like, okay, there are so many variables here, and we're trying to understand which of these are kind of important, which can we focus on here. And then that's how we sort of ended up with the random forest to sort of like limit our analysis onto some, let's say 5 or 6 predictors, or even just 10 predictors.
I see. Like, I don't know if you remember, we talked about it a long time ago at the ASA. I don't know if you remember. Yeah, and then the reason why that I used the random forest was to avoid the colinearity. So, but definitely. I assume that a lot of the rhythmic measures actually correlate each other for sure, based on my research that long time ago. So I was curious.
Yeah, that's definitely one of the perks of using random forest too. It does account for linearity, and then that's one of the reasons that we first sort of like looked at it in exploratory manner and with using for sure.
I see. And then you also mentioned about the waiter's experience to the accentedness, like exposure to the accented speech, like a future direction. So do you have that kind of information? Like that would be interesting to look at it later. I mean, do you have that kind of? Do you actually collect that kind of information? Sorry, I'm asking a lot of questions.
Right. So you're talking about like listeners' experience with.
Right. Like as you mentioned in the future directions.
Yeah, no, we haven't collected data on it. So one thing that I mentioned in the future direction was that, okay, so if we sort of train listeners if we sort of give them exposure to some foreign accented speech, we know that they do get better at understanding speech. They can transcribe better, like in a correct manner, that we know. But what we sort of like know much less about is like, do they sort of like perceive less foreign accent after some exposure? Does that sort of like count as a sort of result of exposure? We don't know. We haven't done it.
Right. Just because it's difficult to detach that rate of exposure when you measure the accentedness, because you're relying on the rating of the accentedness based on like comparing to the acoustic measure of it. But kind of, to me, production perception of accentedness is kind of intertwined together. So difficult to only look at one or the other.
Certainly difficult to tease that apart. Yeah, and it's also possible that before the exposure and after the exposure, the predictors that sort of affecting the foreign accented speech could differ before and after.
Yeah, definitely. Yeah, and then the last thing, sorry, getting one last question that I wanted to ask was that the rate, like you have 1 to 100, that's a quite big range of ratings. And then you could use the quantile type of the regression analysis to see like a different effect on the different range of the ratings. For example, maybe certain variables are more important in the certain range of the items.
Oh, okay, interesting. So right.
Easy to perceive, less accented speech. In that case, maybe listeners using different kind of cues, because all, different ranking cues depending on what kind of speech you're listening to. I hope you understand what I mean. Because we don't use same cue in the same way all the time, right? Because we adjust a lot of things. So
yeah, it's a definitely an interesting question. Like one of the reasons that we Z-scored the ratings for each rater is that we sort of like didn't want to rely on that. Like which range did the listener use, when they were rating the accentedness? Did they vary for different listeners? So that's the reasons that we, one of the reasons we Z-scored the ratings. But if we didn't do that, we could certainly look at like which range did the listeners use, and depending on what kind of.
I think you can still do it if you use the quantile regression analysis. I'm not sure about it, but
right, we should definitely.
Yes, I assume the pitch accented is the one of the highest ranking one, but I don't think that's the case for the lower level of the participant. But anyway, sorry, I'm talking.
Yeah, let's talk more about it.
Thank you.
Thank you.
Thank you. We don't have any question lined up, but is there anyone who might be interested in?
Can I ask a question then?
Yes, sure. Shigeto Kawahara from Keio.
I don't think you have an answer to this, but I'm kind of surprised that F2 in A had an effect while F2 in U doesn't. Because if anything, the vowel quality difference between English and Japanese would lie in U, not in A. So I was wondering if you have any thoughts about why you found that.
Right, yeah, it's one of those things that we sort of like, okay, why A, we do have more details, data of like more like a production results, like a native Japanese talkers produce vowels this way and native like English learners produce vowels this way. So if we looked at those production data, there may be like some answers to that, like how that affected, why it affected listeners' perception that way. So I will be happy to share the production data with you if you're interested.
Thank you.
So thank you. Let's thank Misaki one more time.
Thank you so much.
From now on, a breakout room will be created for anybody who is interested in coming into that breakout room to further discussion or ask questions that you had difficulty asking at this point. The recording of this session will be over now, and then we will meet at 11 a.m. Japan Standard Time in about 20 minutes here to hear the next talk by Moore-Cantwell.